Okay, let's take a quick recap of the last video that you would have watched leading into this video showing examples of those concepts. So the second conceptual video talked about the future value of an annuity, and the idea here is that if you get paid the same amount every year for a set period of time, you can calculate its future value using a much more straightforward calculation than what we've done in the past. We also talked about present value analysis, and this is taking sort of doing the opposite of what we do with future value, and instead of compounding, what we do is discount, and that leads to the present value formula. And again, the idea there is that there might be some future stream of money stated in dollar terms for the future, but what we want to do is put them in present value terms, and the idea there is that we would discount it. We're going to go through some examples of that today. And we also talked about the present value of an annuity in that video. And we started investment analysis. So we're going to go through examples of all of these in this example video. Again, this is taking the place of the lecture that you would have gone to on Friday, January 31st. So to illustrate the idea of a future value of annuity, I want to go back to the example that we used in the video previous to this, where we looked at whether or not a producer should switch crops. And so this table should look familiar. And what I want to do is focus on these. So that's the cash flow that the producer expects to get in each year, each of those 5 years, using the current crop. Now what's important here is that it's the same amount every year. So really, that $160 in year 1, and in year 2, and in year 3, and 4, and 5, that's really just an annuity. And we can calculate the future value of an annuity using a much more straightforward approach. In particular, we would apply the future value of an annuity formula. And that's what I've shown here. And so just remember that FV is future value. PMT is the payment that you get in each time period of the planning horizon covered by the annuity. And this is a compounding factor. Now this is quite complicated, but you've got your interest rate here, 1 plus the interest rate raised to the number of time periods minus 1, all divided by I. So you should be familiar with how to use that kind of an equation. So in the example that we had back here, we actually have the $160 is the payment. We know that N is equal to 5. That's the 5 years that we're going to receive those $160 in each year. And recall that the interest rate was 10%. So if I substitute those numbers into the appropriate right-hand side of this equation, what I end up with is this. There is my payment. That's the $160 per acre per year that I receive. There's 0.1, that's the interest rate. There's 0.1, that's the interest rate, and 5 is the number of time periods. And if I calculate this compounding factor for the future value of an annuity, what I end up with is $976.82, which is exactly what we calculated when we did it the long way of calculating the future value in each and every single year. So this future value of an annuity calculation is a much more convenient way of going about doing this kind of analysis. Now that was for the example that we used from the last example video. What I want to do is actually consider using this for a different example. Let's suppose Jennifer, owner of Happy Crab Sheep Farm, is planning for retirement. She's determined that she needs $1.5 million to pay for her retirement years. Jennifer plans to retire in 22 years. She has an option to invest in Cranky John's mutual funds. If she does invest, she'll earn 8% return. If she chooses to invest with Cranky John, how much does she need to invest in each year in order to reach her target? Now the trick with this question is to recognize that I've given you the future value, right? That's the $1.5 million. So she knows how much she needs at some point in the future, and that's an estimate of $1.5 million. She knows the number of years until retirement, that's 22. She knows the interest rate that she's going to receive, that's 8%. What she doesn't know is how much she needs to invest every year. So we can actually use the future value of an annuity equation to solve this problem, but we work backwards through it. Now one of the things that you're going to see throughout this course is I sometimes get you to work backwards through problems as a way to try to reinforce how you use these concepts, and this is an example of that. So again, let's start with the future value of an annuity equation. We know what the future value is. That's $1.5 million. We know the interest rate, that's 8%, and we know N, that's 22. What we don't know is how much she has to invest in each of those 22 years in order to have $1.5 million at the end of her career. So what we do is we substitute in to that future value of an annuity equation 1.5, so that's $1.5 million, the interest rates, and the number of time periods. So we have one equation and one unknown, and as long as I can calculate this compound factor, I can work backwards and solve for how much she would have to invest in every year. And if you do that, the payment would be equal to 0.027048. Now remember, I stated that future value in millions of dollars, so this payment is actually in millions of dollars. So if we multiply that by 1 million, what we find is that she has to invest $27,048 every year in each of those 22 years in order to retire with $1.5 million. This is a very powerful tool. I'll be really blunt. This is the kind of calculation that my wife and I have gone through when we've tried to figure out whether or not we're going to have enough money saved and how much additional money we may need to invest if we have a particular target future value in mind. So this is really useful. Now remember that the other thing that we talked about in the previous video was this notion of present value analysis. And so present value is just sort of the opposite of future value. The idea there is that you know the future value, you know the interest rate and the number of time periods. What you want is the present value. And we're going to go through an example of how to do that using that crop example from before. Now up here I've got the present value equation, right? So the present value is simply the future value now divided by 1 plus I raised to the power n, where again I is the interest rate and n is the number of observations. In this particular example, I'm still going to need to calculate a discount factor. Now I said something important there. I said a discount factor. When we're dealing with present value, we're discounting. We discount the future value back into present value terms. When we're dealing with future value analysis, we compound. We try to project what it's going to be worth in the future. With present value analysis, we take some future amount and put it in present value terms. Now if we do this, or if we calculate the present value or discounting factor, it's going to be equal to this, 1 over 1 plus I to the power n. Now if I plug in the 10% interest rate that we were assuming here, and the number of time periods that I'm discounting over, then I can calculate a present value factor, or a discounting factor. So if I want to discount the earnings that I have at the end of 1 year, or at the end of the first year, what I would do is I would plug in to I, 0.1, and then n would be simply equal to 1. And the idea there is that I earn the money at the end of year 1, but I want to calculate what it's worth at the beginning of year 1. So there's one time period that's elapsed. I can do that for years 2, 3, 4, and 5. And let me just show you an example for year 5 down here, this 0.621. All I've done is in this, this ratio that I'm circling with the mouse is I plugged in the 10% and then n is now equal to 5. Okay, so that's a reflection that I'm discounting what I earn at the end of year 5 back to today's dollar terms. So now what I can do is I can calculate the new crop present value after 5 years and the current crop present value after 5 years by using these discount factors. And all I have to do is multiply the number in the discount factor for a particular year times how much I was earning from the respective crop in that year. So in the case of the new crop at the end of the first year, I know that there's a loss. That's why it's in these parentheses. We often denote losses in parentheses. So I would multiply $100 loss by 0.909, and what I end up with is a present value of that $100 of $90.91. And if I go through and do that for each and every single year, and then I add those up, what I end up with is the present value of the stream of benefits from that new crop over the course of those 5 years is equal to $543.25. Now again, all I'm doing in any particular year, let's take year 4, is I'm multiplying the discount factor in year 4 times how much I would expect to earn from that crop in year 4 to get $273.21. I can do the same arithmetic to try to determine the present value in each one of those years of the $160 I would get from the current crop in each of the respective years. And if I do that, what I find is that I end up with a total of $606.53. So again, what's important here is that we're discounting things from the future back to present value terms, back to today's dollars. Now, the other thing that's important is that we get a consistent answer. Remember that when we did the future value analysis, there was a higher total for keeping the current crop than there was for planting the new crop. Well, we see the same thing happen. And we should see the same answer regardless of whether we do it in terms of a future value analysis or a present value analysis. Now, we can also deal with, well, let's go back here one slide actually. So this was a calculation where we computed the present value of an annuity in each and every year, and then we added it up. There would be a more convenient way here by recognizing that this is just an annuity, and that in fact, just like how we could calculate the future value of an annuity, we can also calculate the present value of an annuity. Now the equation's a little more complicated, but we can still do it. So let's take a look at an example. This is an example that's trying to pull together a couple of different ideas that I want to illustrate and make sure you all understand. So one is the present value of an annuity. The other idea is that we're now differentiating when interest is being computed. Now instead of annual interest, it's monthly interest, so it's compounded on a monthly basis. So let's suppose you win a lottery that entitles you to receive $500 per month for the next 20 years. You know, we often see ads about these kinds of lotteries on the television. If the annual interest rate is 6%, but interest is compounded monthly, what's the present value of that annuity? So what is that value, what is that annuity worth in terms of present value dollars to you today? So what we would do is we would recognize that now the interest rate that applies isn't necessarily 6%. In fact, it's not that it's not necessary. It isn't 6%. It's 6 divided by 12, which is a reflection of the fact that interest is compounded on a monthly basis. And the number of time periods isn't 20, it's 12 months times 20 years. So 240 months. Now recall from the notes in the videos that the present value of an annuity is equal to the payment that you receive in each time period times this present value factor. Now again, this looks a little bit complicated, but let's remind ourselves I is simply the interest rate and N is simply the number of observations, or sorry, the number of time periods that I'm receiving that payment in. So if I substitute $500 in for the payment and 6 divided by 12 for the interest rate and 12 times 20 for the number of time periods, whoops, what I get is this. Okay, so this is just a reminder that that interest rate is being adjusted for the fact that interest is being compounded monthly, and the number of time periods is adjusted to reflect the fact that interest is being compounded monthly. And so what I could do is then work out the calculation, and what I should see is that the present value of that $500 I would receive on a monthly basis for 20 years is actually $69,790.39. Now, this is actually could be an important number, because if you were fortunate enough to win one of these lotteries, you often have the choice to buy or to receive either those monthly payments or to get a lump sum payment at the beginning. And so what you might do is saying, if the opportunity cost of me investing this monthly payment is 6%, and I'm going to receive that $500 for on a monthly basis for 20 years, it's worth this much to me. And if the lottery was going to offer me less than that, I would say, gee, thanks, but no thanks. I actually want the monthly payments because that's going to give me a higher present value than what they're offering to give me right now. This is a good place to stop. We'll pick up talking about investment analysis and examples illustrating the concepts of investment analysis in class on Monday.